Black holes. They're probably the most mysterious, most mind-bending objects in the entire universe, right? These are spots in space-time so warped that nothing, not even light itself, can get out. But here's the thing. They are not just science fiction. They are very, very real. And in this explainer, we're going to go on a journey from a wild theory scribbled on a page to an actual photograph of one of these monsters. Okay, let's get into it.
But first, I want you to just picture this for a second. Forget telescopes, forget all the science. What would you, with your own two eyes, actually see if you could watch a giant star die and collapse into a black hole? Because what happens is this wild visual paradox. And honestly, the answer to that question really sets the stage for everything else.
Okay, so the star runs out of fuel. Its own crushing gravity finally wins the lifelong battle it's been fighting. As that core collapses, the light trying to escape the surface has to climb out of an insane gravity well. We'd actually see those light waves get stretched out, shifting the star's color towards red. And then, this is where things get really, really weird. From where we're watching, time itself on the star's surface would look like it was slowing down, just grinding to a halt. The star's image would seem to freeze in place, like a final ghostly photograph, before it all just fades to black. And right there, a shadow is born in the universe. Now, here's the crazy part. This whole bizarre celestial ghost story, it isn't just some random fluke of nature. It's the ultimate prediction of our best theory of gravity. See, to really get what a black hole is, you kind of have to relearn what you think you know about gravity.
For centuries, it was all Newton, right? Gravity was a force, a simple pull between two objects. But then Einstein comes along and just flips the whole table. He said, no, gravity isn't a force. It's the shape of the universe. Massive things don't pull other objects. They literally bend and warp the fabric of space-time around them. Think of it like putting a heavy bowling ball on a trampoline. It creates a curve, and a marble rolling by will just follow that curve.
And if an object gets heavy enough and small enough, it can bend that fabric of space-time so extremely that it basically creates a hole with no bottom. That edge, that boundary, is the event horizon. It's not a physical thing you could touch. It is simply the point where the slope is so steep that all paths lead in and no paths lead out. It is the ultimate point of no return.
All right, so the math says these things should exist, but that creates a massive headache for astronomers. If black holes trap all light, how in the world do you find one? You can't just point a telescope and look for a dark patch. So scientists had to become cosmic detectives.
They had to look for the fingerprints, the clues a black hole leaves on everything around it. For instance, you could watch stars orbiting, what looks like nothing, at absolutely insane speeds. Or you could look for the super bright glow of gas and dust getting heated to millions of degrees as it spirals in. That's called an accretion disk. You could even feel the ripples in space-time itself, gravitational waves, when two of them smash together. And the last big clue is watching how a black hole's gravity acts like a lens, bending and magnifying the light of stars that are hiding behind it. For decades, that was it, just circumstantial evidence. But then, an incredible international team decided to try for the Holy Grail, to take an actual picture of a black hole's shadow. To do it, they linked telescopes across the entire planet, creating a virtual telescope the size of the Earth itself, called the Event Horizon Telescope. And just to give you an idea of how mind-bogglingly hard this was, Katie Bauman, one of the computer scientists on the team, put it perfectly. She said what they were attempting was like trying to take a picture of an orange sitting on the surface of the moon, from right here on Earth. And in 2019, they did it. They showed the world this. This is it, the first ever direct image of a black hole. This isn't a simulation or an artist's drawing. It's the real deal, the supermassive black hole at the heart of the M87 galaxy. What you're seeing is the shadow of the event horizon, surrounded by that glowing hot gas, its light perfectly bent into a ring by gravity. Einstein was right.
So now that we could actually see them, we started to realize something else. Black holes aren't all the same. Turns out they come in a whole range of sizes. It's kind of like a cosmic family portrait.
And man, this family has range. On the small end, you've got your stellar black holes born when a single giant star collapses. Then, at the other extreme, you have the absolute titans, the supermassive ones, like the one in M87, weighing millions or even billions of times more than our sun, just lurking in the center of almost every galaxy. And right there in the middle is this huge mystery, the so-called missing link intermediate mass black holes. Finding those is one of the biggest hunts in astronomy right now.
And get this, we have one of these monsters right in our own cosmic backyard. At the very center of our Milky Way galaxy sits Sagittarius A star, clocking in at a cool 4 million times the mass of our Sun. That's our very own supermassive black hole, thankfully keeping its distance.
So for a little while, the picture felt pretty complete, you know? It was all neat and tidy. And then the James Webb Space Telescope came online, and it started looking back, way back, to the dawn of time. And what it's finding is forcing us to completely rewrite the first chapter of the universe's history.
So Webb starts peering into what we call the cosmic dark ages, and it starts spotting these strange things. They were super bright, really compact, and reddish. So astronomers just started calling them little red dots. They didn't look like any young galaxies we expected to find, not at all.
And to really wrap your head around this, we're talking about a time just 500 million years after the Big Bang. The universe was barely 3% of its current age. It was basically an infant.
So what in the world was powering these little red dots, making them shine so brightly? Well, the answer was absolutely shocking. Hiding inside these tiny infant galaxies were colossal, supermassive black holes that were way, way too big to exist that early.
I mean, take the galaxy Kuiper's LRDZ9. The black hole inside it could weigh up to 300 million times the mass of our Sun. A monster like that simply shouldn't have had enough time to form. According to our models, it's impossible. So how did it get so big, so fast?
Well, as astrophysicist Stephen Finkelstein explains, this means one of two things, and both of them are revolutionary. Either these early black holes were gobbling up matter at a rate we thought was physically impossible, or they didn't start from collapsing stars at all. Maybe they were just born big, from some unknown process in the primordial universe.
And so that leaves us right here with this absolutely massive question. We went from imagining black holes as a theory, to proving they exist, to actually taking a photograph of one, only to turn around and discover they were there at the very beginning of everything. So if these cosmic giants were hiding in the shadows of the dawn of time, what other secrets is the universe's first chapter still waiting to tell us?